Everyone. Uh, Quick show of hands, how many of you guys have a Connect app? Great. How many of you would like to leverage AI to migrate that Connect app? Few of you. So those of you who are interested in leveraging AI for migrating this app, hopefully this session will be helpful. And those who have not raised your hands, hopefully this inspire you to kind of leverage AI for this one. My name is Nitin Kumar. I'm a solution architect at AWS. I've been with AWS for more than 2.5 years. Out of this, 2 years plus have been with Atlassian ecosystem. Now, before we get started, just kind of preface it a bit why AWS is here. So AWS and Atlassian have been a partner since 2013. And recently we have signed an SCA, which obviously is a public news that we are helping Atlassian in migrating their data center customers to cloud. This SCA will also help some of the Connect applications to move to the Forge. With this, let's get started. So what are we going to cover today? We'll start with Forge platform. So hopefully all of you are already aware about Forge platform, why it matters, what are the benefits of Forge platform. We'll talk about AWS serverless and why it matters for Forge. Then we'll also touch base on AWS AI ML. I promise I won't do too much of marketing stuff, but there's a reason why we are talking about AI ML services today, because we will be using one of AWS AI services for the actual migration use case. And last, we'll show a working demo on how we are going to migrate a Connect app on Forge. So let's start with Forge terminology. Again, as I said, most of you should already be familiar with it, but we have Forge, which is an Atlassian's app development platform for building secure, reliable, and scalable apps into the cloud. The gist is that you, as developers, do not have to worry about the underlying infrastructure because that will be provisioned and managed by Atlassian. Then we have Connect on Forge, which is probably your entry point on Forge. You will continue to have your Connect apps running on your own infrastructure while kind of start leveraging Forge modules as it goes. We have Forge Remote, which allows your Forge apps to securely interact with external services. And lastly, we have the runs on Atlassian. This is the North Star that everyone should be aiming for, because this will help Atlassian customers to kind of identify and trust apps that are completely built and run on Atlassian, which means no data egress at all. So how does the journey to Forge looks like? Obviously, it's not a binary switch, which means it's an iterative steps that you have to take. Most of the partners will probably still have a Connect app as you have already raised your hands. You will continue to use Connect while leveraging Forge, step by step. And the first step is going to be using what we call as Connect on Forge. Here, your infrastructure will still be hosted and managed by yourself, but now you have foot in both worlds, which means now you can start, leveraging Forge modules for things like authentication, hopefully compute, storage, and so on. Next step is the compute on Forge. This is when you are going to move your business logic closer to Atlassian products, right? When we talk about compute, recently Atlassian have also announced kind of long-running compute. It's still in a preview, but this is a very, very, I think it's important for most of the developers if you have long-running tasks that you want to run on compute. Obviously, after the compute, the next step is migrating your data or your storage on Atlassian, which is what we call as data on Forge. And then the last one, which is when you have the complete app run completely on Forge, which is the runs on Atlassian. So why Forge? As I said, the biggest benefit is for the developers to focus on what you love, which is coding, solving business problems, without having to worry about the underlying infrastructure. This one will be created and managed by Atlassian. Forge is also secure by design, which means ideally there is no data egress from Atlassian Cloud Boundary. Your data stays within Atlassian Cloud Boundary, and your customers or Atlassian customers can trust that these apps will not move the data outside of that boundary. And last but not the least, you have the UI kit or the custom UI that you can choose. Now, one of the important things when we talk about Forge is, as I said, it's built completely on AWS. Essentially, it's a function as a service platform. That function as a service platform is leveraging an AWS service called our Lambda, right? Similarly, as for storage, we have a couple of options, which are primarily your key value store or custom entity store, which is again powered by a service called Amazon DynamoDB, which is again a fully managed, serverless, no SQL database service, which provides, single-digit millisecond latency at scale. I touched briefly on why serverless is important and why Atlassian is choosing to go on Forge or leveraging function as a service platform. As I said, the intent behind it is that Atlassian wants all their ecosystem partners or developers to focus on solving customer problems rather than doing the undifferentiated task like managing your servers, updating your OS patches and whatnot. Serverless improves your go-to-market, it drives higher speed and better productivity. Talking about AWS serverless, we have range of serverless services in our spectrum across compute, storage, database, analytics, workflow, and integration. And in the slides, I've highlighted few of the services that are currently being utilized by Forge as we speak. And obviously, there'll be more and more that will get added as we progress. Now, let's talk about the first step in exploring Forge. You may have heard the session from Tim earlier yesterday, the NPX Connect to Forge tool that Atlassian provide for converting your Connect descriptor file to a manifest file. This tool basically, convert your Connect descriptor to Forge manifest. You would have noticed that primarily the syntax changes a bit from you're shifting from a JSON to a YAML format, but many IDEs can do it today, right? The main approach that you need to consider in this one is that how you can continue to maintain your functionality on Connect while start leveraging Forge modules for the newer task or the newer builds. This is particularly valuable, especially if you have a mature Connect app. You can't just click off a finger. You can't just move to Forge. You want to make it progressive while your team is still kind of getting used to Forge capabilities and all. So how does this conversion looks like? Despite some naming differences that you can say, core concepts still remain the same. So you still have lifecycle events, you still have scopes that you need to define. The only slight difference that we'll notice in Forge Manifest is, there is more explicit declaration that you make in the manifest file. Similarly, in the module definitions, you're still defining kind of the same components. You still define a page with a specific key. You are still placing it in a navigation bar. You are still giving it a name, specifying a URL, and you are still setting conditions on when it will appear. The Connect module namespace that you see on the Forge manifest clearly indicates that these are the Connect modules that your app is leveraging, which is really helpful because the more and more we have talked about runs on Atlassian a bit. So when you have this Connect module definition in manifest, that kind of gives an indication that you're still kind of using Connect modules at some stage. So now that we have seen how Connect to Forge tool handles the conversion of your descriptor to a manifest, let's talk about how or what this enables essentially. The initial conversion that we do is particularly powerful because it opens up possibilities without forcing you to make immediate changes to your infrastructure. As I said, every Connect app provider will continue using their own infrastructure. You will still have your compute, you still have your storage, you will still host it in whatever environment that you are using. But once you start building that manifest files, you have your foot in both worlds now, which means any additional or any new builds that you're doing, you can start experimenting with Forge a little bit. You can use UI components, you can use Forge authentication mechanisms, or whatever the new use case that you have been working with, you start working with Forge CLI a little bit more. Moving your compute to Forge is the next essential step that you will probably take in your migration journey. Now, while running Connect on Forge gave us the ability to add Forge features, moving compute to Forge brings your workload or your business logic closer to your Atlassian cloud boundary. What do we mean by compute here? Now, depending upon where your Connect apps are hosted, these are basically your business logic, or it could be your API endpoints, or it could be your webhooks, right? Now, whether you have deployed this on a server running in a particular data center, or if you're an AWS customer, you might be using some of the EC2 instances to host this logic, or you could be running in Azure, GCP, whatever. The idea is that these are the compute that does the bulk of the processing for you. When you bring that logic closer to Forge, it provides a couple of benefits. Number one, as I said, that you have started leveraging Forge a little bit more. Secondly, you are bringing your compute power closer to the Atlassian products. At the end of the day, all the Connect apps or all the apps that you are building is on top of your Atlassian products, whether you're working with Jira, Confluence, Bitbucket, or whatever, right? But when you're bringing that processing even closer to Atlassian boundaries, you are reducing some of the network latency and whatnot. I mentioned earlier that Forge has already introduced the long-running compute, which means there have been some limits in the past. We have heard from customers that there are some larger data workloads to process, which was not kind of cutting through the function as a service platform. So with the long-running compute in preview, now you can process larger data sets, you can handle complex calculations, and you can execute more resource-intensive operations as well. Now, few considerations when you are moving your compute to Forge. Consider starting with new features. As I said, it's not a big bang approach where you move everything at once. Start adopting it incrementally, right? It's an iterative step. It's not going to be a big bang approach or a complete rewrite of your application. Any new features that you want to build, start building on Forge. Don't build your new features on your Connect platform, please. Simple endpoints, migrate these simpler endpoints first, because your teams are also going to start getting used to Forge capabilities. You start building confidence on your Forge as well. And if there are any non-critical workloads, try to pick those non-critical workloads first. The next step, which is obviously the runs on Atlassian, but before that, we have to move the storage on your Atlassian Forge platform too. Now, again, consider the data flow when you bring your storage in Forge platform. Your compute was already here, but imagine if your storage was still kind of hosted in Connect platform, you're still kind of adding that network latency. When your compute is running in Cloud Boundary, your storage could be hosted somewhere else. When you bring your storage closer to in the Forge platform, you get two benefits. Number one, there is no network latency now. And number two, you're obviously eligible for runs on Atlassian, considering you don't have anything else running outside of these platforms. The benefit that you get with this migration is zero infrastructure management, automatic scaling and reliability, simplified security posture. You don't have to worry about security of your compute or your storage anymore. And lastly, native integration with your Atlassian products. Talking about AWS AI services, as I said that we will show a working demo, but a few of the people have actually turned on our AWS booth and asked about what does AWS do in AI. So I thought these couple of slides will just give you a fair bit of idea on what we do and what service are we going to leverage for this migration. So we continue to reinvent for our customers, which means we have learned what is needed to bring GenAI to our customers. And really, it depends on the GenAI play that you that you operate in, and we have holistically put that into three separate layers. One of the layers is for whether you are a consumer of those GenAI applications, whether you are a producer of those GenAI applications, or whether you're just a customer. So, for example, if you look at the bottom layer of the stack is for providers who are building their own foundational models. If you want to build your own foundational models, you need infrastructure to do that. And AWS has obviously invented for our customers. We have some really cool chips that you can use for inference and training, so like Inferentia and Trainium. Then we also have the fully managed services like SageMaker AI. Some of you have come onto the booth and asked about the DeepSeek models. So yes, answer is you can run those DeepSeek models on AWS as we speak, right? If you're using the DeepSeek R1 models, you can actually leverage Bedrock. But if you want to use other DeepSeek models, you can use other AI services like SageMaker AI. Similarly, on the middle layer, we have a service called Bedrock. I'll touch base on Bedrock a little later because this is one of the services that we are using today for showcasing the migration demo. But what I'll say is the middle layer is primarily, think of it as infrastructure as a service, platform as a service versus software as a service, right? So Bedrock will probably fit into the PaaS model where it's fully managed, it has the guardrails in place, you can start leveraging it, single API, you get access to all the leading foundational models, whether you know anything about RAG and fine tuning and whatnot. But we'll touch base on Bedrock a little later. The last slide is the top slide or the top layer, which is primarily for the customers of AWS. Now you don't have anything to do with training your models, but you want to use the GenAI applications. So for that, we have Amazon Q Business and we have Amazon Q Developer. Amazon Q Business is primarily for customers who want to generate, for example, content, you want to generate business insights from your data, or you can just want to build a bot with your own production data for Q&A and whatnot. And Amazon Q Business does have integration points with various SaaS platforms, talking about Confluence, Jira, and whatnot. Similarly, for the developers, we have Amazon Q Developer, which is primarily is very valuable for developers because it helps you in the entire chain of your software development lifecycle. What it means is whether you are in code planning stage, whether you are coding, whether you are troubleshooting, or whether you just want to write unit tests for your code, Amazon Q Developer can help you do all that and can also help you build your, help you secure your code by kind of figuring out the vulnerabilities that you have into your code. So that's Amazon Q Developer. Now, I mentioned Bedrock. For this particular demo, for migrating from Connect App to Forge, we are actually using Bedrock. As I mentioned, it's a fully managed service that offers a choice for high-performing models. So when we say that you can have a choice of leading foundational models by leveraging a single API, what are the models that I'm talking about? These are models from Amazon. These are models from Anthropic. These are models from Mistral, Stability AI, Meta, Cohere, and so on. And yes, as I mentioned, if you are after DeepSeek models, there's a model catalog in Bedrock where you can use the DeepSeek models too. Now, with Bedrock, you can easily experiment with the top foundational models. You can customize them privately with your own data using techniques such as fine-tuning or RAG, which is a retrieval augmented generation. And you can even write code for agents that execute multi-step tasks. One of the key things about Bedrock is, and many customers ask this, that what happens to the data that we use to train our models? Amazon Bedrock does not have access to your data. Whenever you provision Amazon Bedrock in your account to train your data, it stays within your boundary, right? So it's kind of there's a tenancy isolation that we are providing, which means your data is not used for training the models underneath it. Now, that was a preview of the AI service that we're going to use. Now let's look at practically on the use case that you're here for, which is Connect to Forge migration. For that one, we have picked up this sample Connect app, Jira activity, which is available obviously on the web. While it's a very simple app, the reason we have picked up is that it basically helps us demonstrate two key aspects that is a common usage pattern for Connect apps. Number one, this makes API calls to retrieve data from Jira. Again, a very common access pattern for Connect apps. Number two, it has a straightforward UI that displays the data. Both these will allow us to demonstrate how you can migrate to, for example, Forge UI, or how you're gonna handle the API interaction in Forge. Now, first and foremost, we'll be using VS Code for this one. And we already have the application cloned into a directory called Connect App. The logic is largely contained in your Jira activity.js. Now, considering the time that we have basically done the recorded demo, but we'll touch base more on how you can also get your hands dirty as we proceed. Now, to give our AI companion the best chance of success, we are not starting from the scratch. We are not going to start the Q&A from the scratch. Rather, we will be using Forge CLI to create a project for us using any of the templates that are on offer. So on this screen, you are seeing how we are using a Forge CLI to create an app for us. Next, we'll also be using AdaChat. Now, this is a pair programming tool that we're going to use to connect our VS Code, and so you can still continue programming from within the VS Code, but AdaChat will be connected to Bedrock. And for this particular demo, we have used Claude Sonnet 2 version 2 model, right? Now, what we are going to do is we'll be using Claude Sonnet V2 as our AI in conjunction with AdaChat. This will allow us to work from within VS Code, right? So first and foremost, we obviously need access to Bedrock service. So for that one, we need to have a working AWS account. So what we are doing over here is just authenticating with AWS to give us access to Bedrock. Once you have access to Bedrock, you can choose what models you want to enable. For this particular use case, we are going to use a Claude Sonnet V2 model. Then we will connect AdaChat to Claude. And again, as you can see, the model name is already mentioned that we are using Claude Sonnet V2. Then we'll also help Claude understand our code base. And we do so by providing a repository map for Claude. In addition to the repository map, we'll also provide it access to the key files that it needs to understand. That's your front end, your back end, your logic, and so on, right? Now, we have done all the prerequisite. This is where the real magic happens, the prompt engineering. To set up our AI for success, it's very, very crucial that we provide a clear and crisp communication to our AI agent on what it is going to achieve. Be explicit about what you want to achieve. Start with small and very focused changes. And just like you do in real world, you have to review and test regularly, right? And pay attention to error messages. Error messages will act as your compass in a sense. Now, obviously for this migration, I've created this prompt that we're going to use, but that doesn't mean this is the only prompt that you're going to work. You can obviously, go all nuts on it. Now, we are going to use that particular prompt and paste it in the instructions. So you can see the same prompt has been pasted. AI Assistant will start to analyze the Connect app, the files that we have previously provided to it. And then it starts to map the functionality of these apps to the equivalent front-end and back-end resources. And finally, it goes on to update your manifest file, right? Remember, we have provided access to all these files in the previous step. It also provides you the difference from the Connect app and also shares what kind of tokens that you have received or used for this particular interaction. Now, it's really important if you are writing the code, as I said, to constantly test and deploy. So for this one, after performing an npm install, we do get a linting error. Again, AI is not your magic wand which is going to solve all your problems. You are expected to run into problems as you deploy, even with an AI agent. However, this is easily resolved by Claude, and Ada offers to run the deploy command for us, right? Let's have a look at the app. Hopefully, it's successfully deployed. We go in the project activity, but we will still get an error, right? Now, I could have shown you the actual complete working demo without all these errors. But the reason why we are also showcasing these errors is to provide you recommendation, guidance on where to look for if you run into issues or errors. So for this one, if we do a quick Google search on what this error is and why it's happening, it's apparent that Claude hasn't used the Forge React components. It successfully updates them, but then we get a blank list of projects. So again, after a quick research, we figured out that the V10 of the Forge React library has actually removed table in favor of, dynamic table. And again, Claude offers to apply that fix for us, right? And let's look at the project activity tab again. It kind of works with an error. But this time the error is different. We got an error on egress permissions for project images, right? Again, this time rather than doing a Google search, I'm pasting that error directly into our Ada chat. And we are asking AI that this images are throwing the following error. Help me solve it. What are the issues with it? And Ada will go and look for the documentation, and apparently it does apply a fix for us. Hopefully. Right? So it says we need to add the necessary permissions, and then it goes ahead and apply those permissions for us. Now, a quick refresh, and finally, this works, hopefully. Yeah. Now, being a good citizen, of course, it's always right to kind of say thank you to your AI assistant. However, do not follow the next step, because Claude is going to offer you that you have successfully migrated your Connect app. So it offers you to delete the Connect app for us. Please do not delete your production Connect app, all right? But the idea is that Claude is smart enough to know that since you have migrated from your Connect to the Forge one, so you do not want to keep it. It does offer to delete. Whether you want to delete or not, that's totally up to you. Now, that's a working demo. I wanted to basically cover some of the best practices when you're prompting for Forge. And this is again based on the very scrappy demo that we have quickly built. But primarily, when you are prompting for Forge, always start fresh and stay current. What it means is tell your AI to use Forge React components and ignore the Forge UI to begin with. It will prevent you from getting any outdated solutions. Remember, all the LLMs are trained on the data which is there on the web. So rather than asking them to work on older stuff, stay current, start small, only focus small incremental changes, right? Error messages. Now I've showcased two different approaches for handling error messages. One approach was when we are doing the actual Google search on what that error is, or in general doing a read of Atlassian documentation. And second was we were directly asking that question to the AI that help me solve that issues. Now, there are pros and cons to both of the approaches, but the idea is that if there is a good error documentation available, start from there. Don't ask AI directly. First, look for the error documentation on the web or your repo libraries or whatnot. If it is not, then go to both approaches will work. But this is going to act as your migration compass or your error compass. So please do not ignore reading your error documentation. Then think small and move fast. As I said, incremental changes, small changes, focus changes rather than doing a big bang approach. Your AI will provide more successful responses when your AI had an existing structure to work with. You would have noticed that we created used a Forge CLI command to create a blank, Forge app. The reason is we wanted to give AI structures to work with. You already have a Connect tab that we have provided you as part of the, essential files to work with. Then we have also provided you the Forge structure to work with. So once AI knows those boundaries that these are the structure that they have to work with, they can easily kind of do that transition. Whereas if you work like outrightly without providing any structure, you might get some, hallucination errors in this one. And last but not the least, feed your AI assistant. Again, in this particular demo, I've demonstrated that all the key files that your AI needs to work with, whether it's your front end, your business logic, your manifest file, your connect descriptor file, and so on, provide and feed all those AI files to your AI agent so it knows what is the structure that they are working with. Last but not the least, I wanted to highlight one key aspect, which is when you're using AI, how much does it cost us? So you would have noticed that whenever those terminals we were running those commands, every interaction it was telling us how many tokens we have used or consumed for this particular interaction. right? So in this one, you can see that we have sent 8.1K tokens and 117 are received, which cost just like 3 cents. So what it means is that on-demand Bedrock is actually pretty cost-effective to begin with, right? So when you're using your migration assistant, again, I'm not saying that you will only get this cost because it depends on your connect files as well, how large those your apps are. But the idea is when you're using on-demand, it's not going to cost a fortune. All right. As I said that this was a working demo, we have a limited time, so I cannot show you the real world use case here, but we do have a follow-up session. So we have a workshop at 11 a.m. tomorrow. So in case if you want to try out this AI agents on your own, please do attend that workshop. We will provision some free accounts for you, which means you will have access to Bedrock services. You can create your own prompts, or you're free to use the prompt that I've used in this one. You can bring your own apps and try it out. So if any one of you is interested to kind of explore using AI agents for Connect to Forge migration, please join our session tomorrow or the workshop tomorrow. So with that, I'll probably invite Cal on the stage for any Q&As.